Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. That's the sound of a closing circuit breaker. Circuit breakers are critical for electrical power grid safety. They are designed to quickly and safely switch the flow of electrical power when required. Most importantly, they quickly isolate faults and physically disconnect affected circuits within milliseconds to prevent widespread failures in the power grid. Because circuit breakers often remain idle for long periods of time, regular testing is essential to detect hidden degradation, such as corrosion or insufficient lubrication, to ensure they operate reliably when needed. In this episode of Energy Talks, OMICRON circuit breaker testing experts Andreas Nenning and Elias Alber discuss the various methods for assessing the condition of circuit breakers and the frequency of measurements, focusing on the importance of motion measurements. Andreas and Elias highlight the significance of performing motion measurements in identifying potential issues and the evolving standards that emphasize their necessity in maintenance practices. Andreas Nenning joins me again as an expert guest. In our episode number 96, he detailed the importance of high voltage and medium voltage switchgear testing and the various tests performed to assess their condition and reliability. Elias works closely with Andreas performing such testing in the field. So without further delay, I extend a warm welcome to Andreas and Elias. Thank you both for joining me to talk about circuit breaker testing, more specifically about performing motion measurements in this episode of Energy Talks.
Hi, Scott. Pleasure to be here again. Always nice to be here.
Hello, Scott. Thank you for inviting me.
Well, thank you, Elias, and thank you, Andreas. As a reminder for listeners to our previous episode 96 about this topic that I did with Andreas, there are various tests that can be performed on high voltage and medium voltage circuit breakers to assess their condition. Which ones are the most commonly performed?
Okay, let me answer that question. And mentioning one of the most important tests we usually do on switchgear, starting with visual inspection using thermal imaging and static dynamic contact resistance. Those are the most common. And timing, of course. Timing is kind of core competence of a switchgear. They have to open, they have to close in time. For gas-insulated switchgear, GISs, partial discharge tests and monitoring, also very common to do. And the motion measurements, evaluating mechanical linkage of a switchgear, is also very common. To finalize the list, the control-related tests like undervoltage coil, motor current coil, or the coil current signature. I also want to point the listener to the Secret Technical Brochure 737, which gives you the full list of non-intrusive condition monitoring methods which are available for the tester.
Thank you, Andreas. How often are these condition assessment tests performed?
It's a great question, Scott. So basically, it depends on how important the circuit breaker is for the grid operator and the manufacturer specified. There's a few more factors that are deciding how often the breaker is tested. So for example, the voltage level of the breaker. Is it a medium voltage breaker? Is it a high voltage breaker? The breaker type as well, vacuum breakers, SF6 breakers, or oil breakers, which are the most maintenance intensive. It also depends on the duty of the breaker. So the number of operations or the fault interruptions the breaker has seen, and also to the criticality of the feeder. Basically, testing intervals from 1 year to never, basically. GIS manufacturers often claim that the GIS are maintenance-free, which is not always the case. I would say the frequency for basic tests is more often, and then you have every 5 to 10 years, you have bigger revisions. You could basically compare it to the inspection of a car, right? So the oil and other components of the car have to be changed and checked more frequently. And the same with a breaker. There's certain parts that have to be tested more often and other parts that are not that maintenance intensive.
Okay, thank you, Elias. So that means what test method is used depends also on what parts you suspect to be worn out or to wear out with time. To keep using this car analogy, you might check the engine oil after a year, but you might not check the gears. For what exactly would you use a motion or travel measurement?
Let me start with the overall failure statistics of switchgear. And there's a very famous single brochure 510. They did a statistics on what parts are actually failing. Main parts like interrupter, electrical control, and operating mechanism. Operating mechanism there is shown as having a 50% failing rate. So it is quite important. It fairly fails quite often. So it is, I think, something that should be looked on more closer. And when you look into operating mechanism, what does it mean? What is a mechanical linkage? What are you actually evaluating? And there you start basically with the spring, the energy storage in the switchgear, which is usually a spring, can be other things as well, but most of the time it's a spring. Then a rod is connected, a joint, and different mechanical linkages until you got to the main contact. So the energy drives over this mechanical linkage, the main contacts, open and closes them. What you're evaluating with the motion and travel measurements are those springs, the rod, the joints, and the movement. In the end, always what you want to know is the movement of the main contacts. So how fast they're opening, what the distance they're going, all those mechanical parts. And some breakers even have a dashpot. So when they're opening and getting to the end, damping this end movement in the dashpot as well. So everything related to the mechanical operating of a switchgear is evaluated.
Thank you, Andreas. Which problems can be realistically detected with a motion measurement?
With the motion measurement, a lot of problems can be detected. One of those would be, for example, increased mechanical friction or wear, weak or broken springs, dried lubrication, which would then slow down the whole operation of the breaker. For hydraulic breakers, the hydraulic pressure problems, for example. Also, like Andreas just mentioned, a worn or failed damping system could be detected that way. Mechanical binding or misalignment, incorrect contact over travel. So if the operating mechanism is set wrong, the breaker could move too far, the main contact could move too far or too little. Pole asynchronism, for example, when you have three phases that, for example, one pole would open or close slower or faster than the other phases, or latch problems, for example. And one other thing that is very often not mentioned, but we try to emphasize in our trainings that we do, is that you can also figure out the length of the arcing contact of the circuit breaker. In order to do that, you would need the correct conversion data, which is not often available. It's very hard getting that from the customer, but when you have this data, you could then figure out the arcing contact length as well.
If I can add something, the conversion factor Elias mentioned is basically the factor where you place the motion sensor, so where you do the measurement of the sensor, and the factor which actually shows you the motion of the main contact. So it's kind of the relation between the measured point and the main contact point.
Thank you for that clarification. How accurate does the transducer installation need to be?
It comes actually back to what Elias just said, right? You have this conversion factor. Why do you have that? Because you want to know what the main contact does. That's what you're actually interested in, how fast, total travel, and things like that. But the reality is you cannot really measure right at the contact because it's usually not so easy accessible, maybe in laboratories. You're going to place the sensor somewhere on that mechanical linkage where you easy access that, and it's easy to apply in the field. But the drawback is you're losing accuracy. This translation, this factor between sensor measurement and main contact movement, that factor does not always totally represent the reality. The reality is that you might have kind of delay because there's some damping behavior in the mechanical part. And with the right test devices and the right tools, you can overcome that, or you can make it better and make it easier. So besides this factor, this single scalable number, you can also have a table in there where you can translate from each sensor measurement to the main contact for each point, for each measured value. And then you can have non-linearities in there covered as well. So In the end, you would like to know the main contact accuracy, which should be within 1-2 millimeters. That's what you're looking for. And then it depends on your conversion factor, what accuracy you need on that sensor actually. So what we provide, we have accuracies for around 10 micrometer accuracy, and we usually also use digital sensors, which are more accurate and easier to use in the field anyway.
Okay, thanks, Andreas. Which motion parameters should actually be evaluated and which are just nice to have?
Yeah, so what we are basically trying to figure out is the total travel of the main contact, right? Including the total travel, we also have other parameters, for example, the velocity. Velocity is a more broader topic because you have to measure the velocity of the opening, closing operation, and there you can define velocity zones in our PTM software. So the users have the freedom to define their zones, for example, the initial contact position plus minus value in millimeters or in percent of the total travel. And that way they can define their zones individually. And here it's very important that you have this value because the arc extinction capability depends on the separation speed a lot. So if it's too slow, the interrupting margin would be reduced, for example. We also have the contact wipe that is measured. Contact wipe is the movement after the first contact touch during the closing. The over travel, for example, which is the additional travel after the contacts have reached their final contact position, as well as damping, which Andreas has already explained, and the rebound, for example. That would, in the rebound, you would see worn dampers or hydraulic issues or a loose linkage. Also, like Andreas just mentioned before, it's important when we measure with angular transducers, we measure in degrees. And depending on the linkage, we either have to apply a conversion factor, which would be linear, and a conversion table, which would non-linear movement. So if we have, for example, one lever in place, we would use a conversion factor. And if we have more than one lever, it would be the conversion table that we would use. But like I just mentioned before, it is very, very difficult getting this data from the breaker manufacturers.
All right. Thank you, Elias. How do I know whether a motion curve is good or bad?
Yeah, that's a good question from the people in the field who are using our test device. And how to decide that? Basically, when we look at the parameters we are measuring, like the velocity, right? We have this zone. We know that velocity, when the arc happens, we need to know if that's in a certain range. And that number, only the manufacturer who designed that breaker can define, because they designed it for a certain short circuit current. For a certain amount of time, the circuit breaker can withhold that energy. So there is a technical limit, and only the manufacturer can define that. Sometimes manufacturers might be out of business, the data is not available for whatever reason. Then you have to find other ways, and you can compare with your sister breakers in your system. So the same type, the same make, you can compare and see if they're in a certain range and go with that. Other things, you might get the information when you disassemble them, like the total travel, you know from the mechanical properties what the total travel is supposed to be in commissioning or whatever time. And then later on, you're checking against that. So it depends a little bit on which parameters you're looking at. Some of them you really depend on the manufacturers. Some of them you can really come up with by yourself.
Okay, thanks, Andreas. Can motion measurements replace teardown inspections or just reduce their frequency?
I would say no, you cannot replace the teardown inspections with motion measurements, but you would definitely reduce the frequency of those, because what we just heard with motion measurements, you can find possible problems with the breaker. From my experience, what our customers usually do, they have short intervals for general tests, timing tests, motion tests, contact resistance tests, let's say like 2 to 5 years. And then they have the proper teardown inspections where they have to disassemble the whole breaker, where they're also changing the keys, and other parts of the breaker that just have aging effects on them, which you could, of course, not fix by just performing a motion measurement. So often it's a combination of both as well. When the customers perform a motion measurement and they find an issue, then they, of course, would have to do the teardown inspection and then fix the issue that way.
Are motion measurements complicated to perform, and are they time-consuming?
To be honest, they're slightly more complicated than, let's say, a regular timing test. But you can ease that effort by using good test devices. Therefore, we implemented a few features to make it easier for the user to apply those very useful tests. So, for instance, we have a lot of mounting videos on our OMICRON Energy YouTube channel where you can search for your breaker type and a lot of information on how to do it. Very short, quick overview on how to assemble them on a certain breaker. Then, as I mentioned before, we have digital sensors which make setting up way easier. You don't have to calibrate them on the breaker itself. You plug them in. Our system even detects what sensors you connected. Our software reads that out and provides all the settings for those sensors which are required. We try our best to make it as simple as possible. What is remaining is you need to know the good point to connect. You need a bit of experience, or you ask the manufacturers where they're usually measuring it, or checking what did they do during the commissioning, and following those guidelines, basically. So in short, it's a bit more complicated, but you gain a lot insights on the mechanical linkage, more than you would with no other test can give you.
So are motion measurements equally useful for medium voltage and high voltage breakers?
I would say it's not a black and white question. It's not a yes or no question. I would say they're very important for both, but you would also have to look from a customer's point of view, I would say, on the impact of the medium voltage breaker. For example, the high voltage breakers have larger spring systems and have, for example, could have hydraulic drives, more complex damping systems or damping systems at all, long linkages, which medium voltage breakers don't have. So it's definitely more complex how high voltage breakers are built. Therefore, I would say it's more important to do it, but it's also important, in my opinion, to do on medium voltage breakers.
If it could be not, is it more a question of criticality?
That's how I would answer it, yeah.
Very good. So do you both anticipate any trends that will make motion measurements essential in the future?
When I listen to the market, to our users, I recognize or I hear that the switchgear fleet itself is aging, so they stay in service and operating mechanism is quite exposed to the environment. So it is a higher rate of failure. They use it more than they did in the past because we have more aging switchgear than we did in the past, and it's growing. Yeah.
Very good. Elias, do you want to add anything to that?
Well, as Andreas just said, switchgears are longer in operation. And when you listen to customers, you hear that it's often a requirement to do the motion tests, which it was not like 10, 20 years ago.
It might be also because the test equipment itself gets easier and easier to use. That's kind of, it's always a matter of how much effort it is to do it and how much I gain. So it's maybe also related to that.
Andreas and Elias, thank you very much for taking the time and joining me for this episode of Energy Talks.
Thanks, Scott. It was a pleasure to share our knowledge.
Thank you, Scott. It was very nice joining you on the podcast.
Thank you both for being here with me. And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.